Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled Planet X Reveals How the Universe Began and How It Is Connected. Now, in Article 560 entitled Planet X Reveals That Planets Are Smaller Versions of Their Parent Stars, I detailed how celestial objects have two types of matter creation events. Matter creation which increases the size of the object, and matter creation which ejects matter to the outside. The ejected material to the outside can have different levels of energy, with the highest level containing core material which cannot be replenished. So the core which remains behind will now be smaller in size. Galactic nuclei also have two types of ejections. Ejections which create smaller versions of themselves, or core ejections, which contain part of the galactic core and turn into quasars, and lower energy ejections of newly created matter with no core material, which turn into globular clusters, break up into stars, and thus populate the arms of the galaxy. And the one of the ejections is illustrated here, and that is the one that turns into a quasar and then turns into new galaxies, because in the course of time the quasar will start ejecting its own material, so it will grow into a galaxy with arms, and that's looking like that. You may look at Article 126 entitled White Holes Instead of Black Holes at the Center of Galaxies for more details. Thus, just as in stars, galaxies have matter creation events which result in the formation of another version of themselves, the quasar, and matter creation events which goes into the increase of their size, in other words, globular clusters. And this is illustrated here, how galactic cores have these two types of ejections, and the core ejection is the one shown in red, which creates smaller versions of the parent galactic core, and in other words it leads to the formation of new galaxies. And the lower energy plasma ejections, the ones in orange here, which turn into globular clusters or stars, which then populate the arms of the galaxy. And these are not one star though, they turn into possibly millions of stars. So the second type is made up only of newly created plasma, whilst the first type will have core material in it. Then the globular cluster material is lower in energy than the quasar material. So its core is lower in energy than a quasar's core. But matter creation and core ejection occurs in exactly the same way. The globular cluster core outside the body of its parent encounters an outside environment at a much lower energy than it has, which triggers core ejections so that it splits into smaller pieces, and the smallest pieces split into even smaller pieces until the cluster breaks up into individual stars. The continuously splitting cores also create outer layers and nebula clouds outside the body of each object, thus creating an environment that eventually their outer cores are in equilibrium with, thus stopping the core ejections and matter creation events. But as stars move away from each other, low energy regions appear which trigger core ejections. If a triggered core ejection is small, it turns into a planet. And this is illustrated here of how a globular cluster ejection, so this would be the globular cluster, but it's starting to already split into pieces, and each of these pieces will have a piece of the core, and it will immediately start creating its own matter. It may even have some of the matter that had already been created of lower energy by the core. But as they split, they continue to create matter and splitting. But the original core will be a piece of the original core will be in each of them. And as time goes by, these move away from the central object of the globular cluster, and these objects will continue to break up, so into smaller and smaller pieces. And the ejection is toward the region of less energy and thus less populated, so it's outwards away from from, say, if you have a group of 3 objects close together like this, the ejection will tend to be outwards, away from where they are close to each other. And here you see NGC 6388, which is a globular cluster in the Milky Way galaxy. And you can see that it is much denser at the center than at the edges, indicating that it is the product of repeated core ejections spreading out from the central core. In other words, it's the original core which came from the galactic nucleus, which starts splitting, and as the smaller pieces came out, each of those pieces went on splitting into ever smaller pieces, so that you have the spreading number of stars spreading out from the center of the globular cluster. And you can see ring patterns in many places, and these are where stars were ejected away from the same point or the same parent core at about the same time. So they form these ring-like patterns. And so as breaking up cores or forming stars move away from each other, any region with a lesser population causes a drop in the energy of the local environment. So initially this is what you have. And then eventually they move further away from each other, and that creates a region in the center which is now lower in energy. And that triggers a matter creation event. In other words, a core ejection. And it will then have another piece of this core here. So another star is then forms in this region. So any holes that form due to objects moving away from each other is filled in because matter creation events are triggered by any region of lower energy in the environment of one of these celestial objects. Well, they may be termed very large stars, which then will eventually break up into smaller stars. So galaxies will tend to move away. This occurs with galaxies as well, because galaxies will tend to move away from the parent galaxy, and stars will tend to move away from the central globular cluster core. And that is because ejections are always outwards, in other words, away from the parent. And that's why you then have regions which develop, which are lower in energy between the stars or the galaxies that are moving away from their parent galaxy. Thus, all stars contain a piece of the parent galactic nucleus, and all planets contain a piece of the parent stars, so that all objects in a galaxy are connected to each other. This mechanism also suggests how the universe began. It most likely began as a huge, extremely high-energy plasma core, which through core ejections broke into smaller and smaller pieces, eventually forming individual galaxies. And then galaxies did their own ejections, which created more galaxies. As galaxies spread out, low population regions or energy vacuums appear, which trigger more core ejections from older galaxies, so that galaxies spread out and away from the original universal core. So in conclusion, matter creation and core ejections are occurring all over the universe. Celestial objects form themselves from the inside out through matter creation and create other celestial objects which are smaller versions of themselves through ejecting part of their cores. Planets are thus smaller versions of their parent star. This means that all planets are connected to their parent star and all stars to their parent galactic nucleus. In addition, all galaxies are connected to their parent galaxies, and all galaxies to possibly an original supergalactic core, so that the whole universe is connected. These are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.